Hello, everybody. Actually surprised to see that many people in the last session of a conference. You must be having a good time, right? Good. You like the conference so far? What did you like the most so far? ChatGPT, yeah. Yeah, interesting, right? Okay, so first of all, this is an introductory session about Blazor. So if you know all about Blazor already and you're already using it in production or whatever, this is not the session for you. I'm starting at the very beginning. So if you want to go to another session, I won't be offended. Just feel free to go. Just setting expectations here. And nobody is leaving, so that's a good sign. Oh, one person is leaving. Okay, no worries. Okay, this session is based on a learning path on the Blazor site that you can access on this URL. If you want some trial code for that, you can access it freely. If you don't have a Blazor site subscription, just send me an email, and I will give you a code, and that gives you, I think, a month free access or something, and you can take a look at it if you want. All right, so what's the plan? So first of all, what is Blazor, right? That seems like a great way to start. Second, we're going to into the basics of component building, because that's really the essence of building a Blazor application, and we'll see that shortly. And then, if we have time, we go into more advanced component capabilities. So that's the plan. I'm assuming basic knowledge of C# and ASP.NET Core, so things like what is ASP.NET Core, how does it start up, what is dependency injection, that kind of stuff. So I expect that you know that. And for the rest, we're good to go. All right, so let's start with a traditional server-side ASP.NET Core application, right? Let's say it's an MVC application. So how does it work? We have a server on the left side and a browser on the right side. And what happens? The browser does a request to the server. Server receives the request, and it creates some kind of response, right? How does it do that? We have a controller, maybe with MVC we have a controller that receives the request. And the job of the controller is to then gather some data from some database, for example, put it in a model, that's the M for MVC, and then use that data in a view. So use that model data, these objects, in a view, and the view is rendered as HTML, right? So basically it's just HTML in combination with CSS that is sent to the browser. So let's say that first page has a button, submit button. User presses it, and the whole thing repeats, right? So the form is submitted, and this time it's a post request. Controller receives it, does something, retrieves data, manipulates data, changes data, whatever. We have a view, it's rendered back, and the browser renders it. So conclusion, the browser is very, very lazy here. It doesn't really do anything, but it just sends requests, receives stuff, and it doesn't have any logic by itself. All logic, all UI-related logic is on the server, right? When we go to a single page application, we move that UI logic to the browser. So now the browser has the UI logic. So that means that all the views and all UI interaction is handled by the browser. And we still have a server-side application that handles data. And it could be a web API, for example. Some back-end application that also has a controller and maybe models, but not views, because the views are now in the browser. And the browser handles all interaction. So when the user clicks a button or goes to another tab or to another page, that is handled by the browser. So why is this called a single page application? Because the browser on an initial request the browser will get all UI logic and also all the UI itself, so all HTML and all everything related to the UI in one go. It's just a single request, gets all, and then it can be autonomous. It basically is autonomous in terms of UI, and it just needs the API for data. So that's a single page application. Now, we used to have all kinds of frameworks, we still have, to create single page applications called React and Angular, right? These are very Vue even. And these are all JavaScript libraries. So the thing Blazor gives us is another framework to create single page applications, but now we're not using JavaScript anymore. Sorry, oh, this was my nice animation. We use C# instead in the browser. So we can create UI-related logic in the browser. And before that wasn't really possible because, yeah, the browser only understands JavaScript, right? Doesn't understand C#. And Blazor makes it possible to do that. And so basically the definition, this is my definition, by the way. The definition of Blazor could be it's a single page application framework that lets you write C# on the browser side. So, and when we do that, we create components. And components are reusable pieces of UI. So you create some part of your application, UI-wise, and it's a bit of UI design, and it's a bit of code that you write for that. And that's called a component. And you can reuse that component on different pages. And when we say a page, a page is just a composition of different components. So you can have one page that have this composition, and another page that have another composition, and maybe reuses components from the first page. Right? So that is component building. And that itself is also not new, because that was also going on in React and Angular. Same thing. The only difference is that was using JavaScript instead of C#. Okay, so Blazor has two hosting models. So basically there are two versions of Blazor. And the first one is called Blazor WebAssembly. So with Blazor WebAssembly we create components for the application, like I explained. The server sends these components to the browser, and then the browser executes these components, executes the code behind the components. It's actually parsing the code behind it. But this code is contained in assemblies. Just like with every .NET application, when you build your application in Visual Studio, you get assemblies, right? And these assemblies have IL, and then all that kind of stuff. And it's the same thing here. So the browser will receive assemblies, but of course it cannot read assemblies by itself. It needs something to, well, it needs some runtime basically for these assemblies. And this assembly is in fact a .NET runtime. And this .NET runtime is sent to the browser as a WebAssembly application basically. So the browser, newer browsers from the last years, a year or three I think, they support WebAssembly in addition to JavaScript. And WebAssembly is like IL in .NET, intermediate language. It is not meant for humans to read or write. It is meant for machines to execute, right? So that runtime, that .NET runtime is sent to the browser, and that runtime is used to read the components and to execute the code that's inside the components. Okay? So that's Blazor WebAssembly. And again, this whole thing is just one request to the server, it sends everything over, and then the browser can handle all UI logic autonomously. Second model is called Blazor Server, And Blazor Server kind of simulates this single-page application feeling, but it isn't really a single-page application, because the browser will just receive the rendered components. So the components are actually rendered on the server, so the HTML is generated on the server, sent to the browser, and then the user does something happens, and that event is sent to the server again, and the server is, oh, wait a minute, this happens, so I have to render the page now like this, and it sends the update to the browser. And that is done with a connection between server and browser, and it's called a single R connection, and single R is a technique in ASP.NET Core that can maintain a permanent connection between server and browser that is two-way. So the updates are sent to the browser and the events are sent to the server in one pipeline, basically, in one bidirectional pipeline. So it seems it's a single-page application, but it really isn't. And this is also a model that is not really suitable for a lot of scaling. If you have an application with many users, then probably the first hosting model is better, because then you actually put the workload in the browser of the user. So that's more scalable than putting it in the server, because then the server has to grow, right? Okay, now, important thing, it doesn't really matter which hosting model you use. The only difference is that the application starts up in a different way, but the components are exactly the same. So you just have to learn one way to build components, and then you can apply it to both hosting models. There's one but, and that one but is, of course, you cannot do everything in the browser that you can do on a server, right? There are just physical limitations. For example, creating a file or accessing the file system, yeah, it's just not allowed in a browser, but you can do it on the server. Or accessing a database directly. That could also be a thing in the browser, but you can easily do it on the server. So while you're designing your components, you have to keep that in mind, right? Am I writing code for the browser itself, or is it executing on the server? All right, let's do a demo. Server and client-side Blazor comparison. So I have a fresh Visual Studio here. I'm creating a new project. And let's do a Blazor. I know it's a little bit small maybe, but I zoom in later. So I can type in Blazor, and I have a choice here. There's a Blazor server application or a Blazor WebAssembly application. Which one do you want to see first? Server. Good. We give it a name, and let's create one. Now, when I run this application, I get this template that is provided by Microsoft, which is kind of cool already. We have Hello World, of course. But we can also go to counter here, and we can click to increase the counter, and we can fetch some data with some weather stuff. Great. Now, one thing that is interesting here is that the way this is updated. So when I press F12 here, so I go to the browser tools, and then I select this div here. Let's see if I can make this work. You can see kind of the HTML structure that is used here. And when I click on the button, it's hard to see, but you can see that only the P is updated. And when I open that, you can see that only the number is updated. So the whole HTML remains static, and just the part that was updated, well, is re-rendered by the browser, basically. So that makes it very efficient. So Blazor is very efficient because there's a smart div mechanism going on. The way it works is that it has an object model for this page. So every tag you see here in HTML is an object in Blazor. You don't see that, but it works behind the scenes like that. So you have this object model, and it has this object model in memory, and when an update is received, it will re-render the component and all other components that have to do with it, and it will compare the new object model to the old one, and then figure out what the browser should update. And that principle is also not very new, because if you use React, for example, it has the same kind of logic. Microsoft didn't invent this all by itself. It lended a bit from the competitors, right? As usual. Oh, can we cut this part? I'm an MVP, so. Okay, so but that's how it works, right? So there's this smart diff mechanism going on. So that's a very powerful mechanism. But as you remember, this is a Blazor server application. So the single R connection I explained, only that one update will go through the connection. So on the server, it will figure out what to change in the browser, and only that will be sent to the browser. Alrighty, cool. Now let's see how this sticks together. So we have this, touchscreen. I hate it actually, touchscreen. I have to turn it off. Okay, so we get there at some point. Okay, so I have this typical ASP.NET Core application structure, and when I go to Program CS, you can see we have a builder, and we have a services object, and we add all kind of stuff to the dependency injection container. In this case, also stuff for server-side Blazor. And the weather forecast service is added to the container. And at some point, we map a Blazor hub. And hub is a signal R term. So a hub means it's a class that receives the updates from the signal R connection, right? And when the request isn't meant for the hub, it will fall back to this /_host page. So what is that? Let's take a look. _host, where is it? It's actually in a folder called Pages. And this host, no, don't touch the screen. This host file has this. It uses a layout page, just a normal ASP.NET Core layout page you also use with MVC and stuff. And it uses this component tag helper that says, okay, please render the component app here. Basically says here. So app is our startup component, it's our mother component, our root component, right? Or father component, because diversity, right? So have to be careful. Okay, so what is app? App is a file. It's called app.razor. So components typically have the razor extension. So in app.razor, we have just a composition of components, like I explained, right? So this component uses other components, and that's typical for a Blazor application. In this case, however, these components that you see here don't have a visual appearance in the browser. They have functionality, but there's no visual appearance. This is called a router or however you pronounce it, depending on if you are in the United States or in the UK. But anyways, what this first component will do is it will look at the URL in the browser. And it will try to match that URL with a certain page in Blazor. So it does that with router, and it says, okay, this is the assembly you have to scan for pages. So look in this assembly to see what pages you have and try to map these to the URL. And if you find a match, just render this, this component using this default layout page. And if you don't find it, just create a page with a not found title and do some nice text there, right? Just print some nice text. Sorry, there's nothing here, or whatever. Okay? So that's the route. So now the next step is to look for components that are actually pages, that map to a URL, right? So when I zoom in here, don't touch the screen. Yeah. We have this pages folder, and here are all the components that are pages. So one thing to remember is a page is just a component. A component is not necessarily a page, but a page is always a component. The only difference is that a page is a component that has this page mapping going on, right? So for example, when I go to index.razor, you see this page directive. It starts with page, right? This is information for this router component. So this it will be read by the router component. We'll see, oh, wait a minute, this is the landing page. This is the root. So when there's nothing behind our main domain URL, then I will render this. Hello world, welcome to our new app. How are you? Or whatever, right? That's it. Now these pages these pages also use layout pages. So the menu you saw on the left side is in a layout page. So that's just a shared component. And we have a main layout, Razor, that renders this, this sidebar with another component called nav menu. Not going to show you all that, but that's how it works, right? It's just it's rendering a different component for that. Okay. By the way, what you see here is all Razor. It's called Razor, right? The syntax, it's also used in MVC, it's used in Razor pages. This is HTML mixed with C#, basically. And you can use tag helpers, C# code, and whatever in these components. So, okay, so index has root, and when we go to counter, for example, here, it has /counter. So when I type in /counter in the browser, it will end up at this component, right? All right, so this counter says, okay, current count is at current count. So whenever something starts with this @ sign, it is kind of referring to something in C#, in .NET. Right? That's how Razor works. So what is current count? Well, it's defined here as a private field. It's just a private field here. And it is in a code block. So with Blazor, in components, you can have code inside your markup with a code block. And you can just define a private field here and define a method, and then you can actually call this method here from the markup. So here we say, here we have a button, and when I click on it, just please execute this method here, and then it increases current count, and that's all it does. And this is very powerful, because the only thing I do is I update this private field, and the UI will automatically be re-rendered. So that's very powerful. In a smart way, right? In the smart way I showed you, it will only re-render the part that was changed, the count itself. Cool? You like it so far? All right. Now, let's do the same thing with another project. Let's do a Blazor WebAssembly application. Right, and let's see how that's different. So we. Does CSHTML and the Razor page used simultaneously? Sorry. There's also CHTML pages. Yeah. So that's a good. So CSHTML is also Razor, but it's not a Blazor component. It is what Blazor server does actually. It is actually using the Razor pages engine to start up the Blazor application, and these HTML files are around the Blazor application. These are actually Razor pages. Good question. So let's go to this WebAssembly application. So this WebAssembly application, when I run it, it's exactly the same. I hope, at least. Yeah, hello world, counter, everything is the same, right? So now let's go take a look at the code here. So we go to Program CS, and it's a lot shorter. It just says WebAssembly host builder. We now suddenly have a WebAssembly host builder, and we create some root components, and we start adding services to the dependency injection container, and we call run. That's basically it. And that's because this code is executed on the browser. So we don't have a server, we don't have Kestrel, we don't have a web server at all. This is directly executed in the browser. So we don't have a pipeline with endpoints and that kind of stuff. This is a browser application. Okay? Now, let's go to what happens here. Let's go to the pages folder. Let's first take a look at app.razor. No, let's go to www.root first. So in www.root, so I told you just now that the Razor engine is used, the Razor Pages engine is used in Blazor Server, but we don't have that here. So the way it happens here is we just have an index.html file, which contains the whole HTML structure, and at some point it loads a little JavaScript file called Blazor WebAssembly.js, and that will make the bootstrapping of the application possible. So when we take a look at the components, so starting from app.razor, it's exactly the same, right? So app.razor is also the router, found, not found, blah, blah, blah. When we go to index.razor, we have page slash, it's exactly the same, right? So counter as well, same code. So the only difference is the way it starts up. The first one started up on server, this one starts up in a browser. For the rest, the component creation is exactly the same. Cool, right? All right. Now, let's go to a more elaborate example that goes beyond hello world. Close this. Take a look at that. Not taking a look at that. Let's see. I closed it by accident, I think, because I wanted to have this. Yeah. So let's see what this application does. Let's run it. And if you were at my gRPC workshop this morning, did anybody attend that? Good. Then this looks very familiar, right? It's the same application. This uses the gRPC API in the background. But anyways, it's a very simple application. And you can see that we have a list of conferences. You can press proposals. I can approve my own sessions. I can add a session, that kind of stuff. And this all works with the same smart div mechanism, right? So when I now press F12 and take a look at everything, you will see that only the stuff that is changed actually is re-rendered in the browser. Not doing it right now because of time issues, but you get the picture. Okay, how does this work? Well, this uses data. So we have these API service classes that are used to talk to the API. I'm not explaining these. But when we go to the components, to the pages, we see the conference list here. It's a conference list component. And that contains Razor. And it uses a variable inside this Razor called conferences. And when it's null, so in other words, I've not loaded the conferences yet, it will just say loading. And if not, it will display a table. And in the table, in the t-body, so we have a header here, right? Header of the table. And then in the t-body, we say for each conference in conferences, render a conference list item component. So this is very powerful, right? We can just use C# in a familiar way to render components like this. So now I get a conference list item component for every conference. So how do I get this conference? Now we can just inject this service class that I showed you earlier with the inject directive, and then introduce a code block. Again, this is just a code block. Define the variable, and then override a lifecycle method called onInitialized async. And that means when you are initialized, execute this code. It's an event, right? It works like an event. And the code fills up this conferences variable with the result of getAll that I call in the service class. Now the cool thing is, because we have this smart update mechanism, etc., initially this will display loading, and then automatically when the conferences arrive, when they are loaded, the view will update. Automatically, I don't have to do anything for it. I'm just putting something in the conferences variable, and ploof, we have a table rendering. Ploof, it's English, right? As well. Okay, I cannot translate it, so that's hard to do. All right, cool. Now, let's take a look at this conference list item component. So in the conference list item component, I've put it in a separate directory, as you can see here. I have components, I have pages. So as I said, pages are just components with the page directive, but I keep them separate in this application. So that means conference list item doesn't have a page directive. Let's see if that is correct. Yeah, it's correct. Okay. So here we have just a TR. So this component is meant to be used within a table. So it just renders a TR, and then it takes a conference and renders that out in a certain way, right? And there's an if statement. If the conference attendee total is higher than 5, then use strong, and else use a normal TD. And I render a link as well to the proposals. That points to proposal/conference ID, which also is a property of conference. Now, when I go to the code, we see that there's a property defined in this case. So we had privates before, and now it's just a property with a getter and a setter. And it's marked as a parameter. There's a parameter attribute here. So what does it mean? It means the value for this property can be set by another component. That's all it means. Right, so another component can manipulate this value. So how can we do that? By using this familiar attribute-like syntax, attributes in HTML, we can fill it in. We can just say conference, so we can see this is lowercase because that's customary with HTML attributes, right? And the property was how do you say it? Yeah. But it understands it. And I can just assign it a conference. So what is conference here? Conference is the thing I have in the for each loop, right? That conference, we're passing that in. So this conference list item gets its own conference object and renders it by itself. Cool, right? Okay, we also have a proposal list And the proposal list works a little bit differently, because when you take a look at the proposal list, well, this is kind of the same stuff, right? We have proposals, we have a table, blah, blah, blah. But when I scroll down, there's no code segment. Where is the code segment? Well, with Blazor components, you can separate the code from the markup. And you want that probably, right? Because you don't want it in one file. You want to separate it. You can do it in two ways. So this, all you see here is just to keep us developers happy, the peppy, and we can just write a component in a very familiar HTML-like way, right? But in fact, when this is built, when this application is built, this will just become a class. And this class will contain all kinds of calls to render element. And it just writes the code, render element, div, this attribute, blah, blah, blah. But that's not very intuitive for us humans to read. So that's why we can just write HTML and make nice hierarchies, etc., etc. But eventually it will become a class. And the code we include in the code block will be part of the class. And that class is put in assembly, sent to the browser when it's WebAssembly, and then executed there. So the actual razor is not part of the assembly. Now, what we can do is we can, the class that is generated is a partial class. So we can create another partial class and put the code in there. That's one option. The other option we have is more powerful than that, because when the class is created, it derives from a base class called component base, if I'm not mistaken. I think it's component base, yeah. So that's the default. But we can deviate from the default. We can say, now instead of inheriting from component base, please inherit from this class instead. So we can create another class, and instead of having razor, it can contain the code, just the code here. So we have the parameter here, we have the enumerable list of proposals, etc. And you can see this derives from component base. So that is not an option. Eventually, you have to derive from component base. So it basically works like this. If you use a code block, for example, for conference list, we have a generated class, and the generated class automatically derives from component base, which is part of the Blazor framework. And now we have a proposal list model. And we say proposal list is generated, but we have this directive, and we say, okay, derive from proposal list model, and that works as long as proposal list model derives from component base. And we can of course extend that. We can put as many layers in between that we want. So this even adds to the reusability of code and components in Blazor. So components by itself are reusable, and this makes code even more reusable potentially. Okay, cool. Oh yeah, that's just a stupid name I chose. I had to think of something. You can call it whatever you want. I called it model. It's probably not the best name. Okay, now let's go take a look at some other possibilities. I don't have much time left, but I have another application prepared, and this is really this contains a very nice component, and you want this code, and you want this in your production apps straight away, because this component you see here with a nice lady is amazing, and I'll show you why. When you click on it, you see? Isn't that amazing? Thank you. And of course, this is the same component, right? And you can play a little game, and okay. So how does this work? Now, we have this. Okay, it's the last session, so we can have a bit of fun, right? Let's see, what is this? This component is called profile picture. This is the component. So this is this readable? Yeah. Okay, so we have this little markup, and we have this private string CSS class, which the default value is circle. So now, where is CSS class used? It is used here in this IMG. So we're just rendering an IMG, a picture, and we give it CSS classes, and one of the CSS classes can be the value for this private field. Right? So this is a more advanced scenario. We can just use it wherever we want. And by default it's circle, so the picture will be a circle. But when I click on profile here, on this link, when I click on the image, when I click on the image, it is an on-click event, I can say, okay, CSS class, when it's circle, it becomes null, and the other way around, right? Just put the code here. And what I'm doing here is I can either put this in a lambda expression like this, but I can also just say here, profile click. And profile click is just a method with the same code. It's your choice, right? You can either do the quick and dirty way or use a separate method, whatever you want. So that doesn't really matter. Yeah, you can do that as well. Yeah. So that's cool. So it changes the value, and again, the UI will automatically update. And we have this nice feature here called child content, which is of type render fragment. So how does that work? And this render fragment is actually rendered underneath the picture. And if you paid attention real close, do I have it still open? No. But the left one didn't have a caption, and the right one has this nice caption, right? So we want to set this caption by the component that uses this component, right? That component has to be able to give this the value, just like we had a parameter just now. So we have this child content, which is a parameter, and that means that child content can be any render fragment, and render fragment just means any fragment of Blazor. So you can give it any fragment of Blazor, and that will be rendered on this spot, on this beneath the picture, right? So let's see how this is used. So when I go to this index Blazor, you can see that profile picture is rendered here, and it just gives the content here as, well, just content, just the inner HTML basically for this component. And that will be the child content. And the component can just choose where to render that inside the component. And this can also be Blazor. We can also do div here, render divs here, or other components, whatever we want. So that's a templating mechanism. You can create components that render templates of other components. That's a very powerful mechanism. Now, in 2 minutes, there is beer, so I have to hurry up. Yeah, so this code is downloadable at my GitHub repository, so please download it. I don't have the time to show everything, but there is a nice component here called the benefit selector. So when I run this and I go to employees, I see a list of employees, and I can go to the thumbs up symbol, and we have this benefit selector. Now this benefit selector renders a number of benefits, and you can see some are highlighted, and I can click on it, and when I click on it, a date appears, and I can set an end date. And as soon as I click on it, you can see the parent component, so the component that renders this child component actually also updates. It has changed the background color to green here. So that's a child component communicating to the parent component. And that's also possible in Blazor. So how does it work? So we go to the benefit selector component here. And it has a, I called it benefit selector base here. That's probably a better name, right? Yeah, benefit selector base. And you can see it has a parameter employee. And it has this benefit data service, blah, 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 all the same stuff here. But it also has an event callback of bool. And it's called onPremium toggle. And this works like a delegate. So that means that this method can be called by this component. And another component can put a method inside it. So, for example, here we see that when the checkbox is changed, we call onPremium toggle. But we don't know what is inside premium toggle, what method is inside. But the only thing we pass in is a Boolean, and the Boolean represents if there are any benefits which are premium and are selected. Right? It's just a Boolean. It's either true or false. So now the component that renders this benefit selector can actually pass a method in, and that's really cool. If I can remember where it was, employee over. Let's see, benefit selector, employee overview. Yeah, here it is. So here we have employee overview. And you can see benefit selector is rendered here, employee is passed in, and we say onPremium toggle, and now the parent component that renders this component gives a method that has to be executed by the child component when something is selected. Right? So it says employee has premium benefits is B, and B is the Boolean that was passed in. And now the parent component changes, and I can react to that fact and update the parent component as well. So this is a little bit more advanced, and certainly for the last minute of the last session, right? But I hope you get a feeling of how Blazor works and how powerful it is. And with that, thank you very much, and have a great evening.